So this section is covering linear functions and their graphs. So when we talk about linear functions, what we mean are functions that represent lines. Okay. So there are several ways that we can go about graphing these. The first way that we're going to talk about doing that is by making use of the x and y intercepts. So the thing to note is for the x-intercept, that occurs when it crosses this line. And when it crosses this line, the y-coordinate is 0. So that means it's of the form a 0. The y-intercept is where it crosses the y-axis. So there we see it's up on this line. So that means it's of the form 0b. Okay? So when we want to find the x-intercept, we'll just set y equal to 0 and solve the equation for x. That'll give us one of our points. The y-intercept, we set x equal to 0, solve for y. That'll give us another point. Then when we have 2 points, we can just graph it as we normally would. Okay? So let's go ahead and see what that looks like here. So I have, in this example, x plus y equals 4. Okay? So I'm going to start by setting x equal to 0. And that'll tell me what the y-intercept is. So I have 0 plus y equals 4. That tells me y equals 4. So my point is 0, 4. So I had 0 for x, 4 for y. For the other one, I'm just going to set y equal to 0. X plus 0 equals 4. So x equals 4. Y equals 0. So that tells me it's 4, 0. So I'm going to start here. 4, 0. Then 0, 4. Graph those 2 points. Then you can go ahead and use a straight edge or a ruler or the edge of your book or the edge of a paper. It doesn't really matter. And I'm not going to be particularly picky if you have a perfectly straight line. I'm more interested that you're getting the general idea of these down. For more detailed graphs, we'll make use of graphing software. In particular, we'll make use of it on Desmos. We'll get into that a little bit more in our next section. Okay? So that's what it looks like when we're trying to find the x, or to find the intercepts in order to graph these. Okay? So to find the x-intercept, set y equal to 0 and solve. To find the y-intercept, set x equal to 0 and solve. Those are your 2 points, then graph them. Now, unfortunately, this only works if the x-intercept and the y-intercept are not the same. If they are the same, then we only get 1 point. So this method won't work for all of them. Instead, we're going to be looking at converting these into what is called slope-intercept form. Now, slope-intercept form is the form y equals mx plus b. Okay? Well, to find y equals mx plus b, we'll note that m is the slope and b is the y-coordinate of the y-intercept. Okay? Now, let's talk about the slope for a second. The slope is a general gauge on how steep your line is. Now, what that means, for example, is how far do you need to go up or down if you go 1 unit to the right. Here we go right 1, down 1. So that means my slope would be -1 over 1 or -1. Now, the formula we use, m equals y2 minus y1 over x2 minus x1. Okay? Now let's go ahead and take a look to see how we can find the slope if we're given a couple of points. So let's say they give us this point here and this point here. Okay? Now we'll note that this point here is 4, 2. This one here is 3, 4. Okay? Now, we need y2 minus y1 over x2 minus x1. The first thing I recommend you do on any of these slope problems when they give you some points is I recommend that you go ahead and find out which one is your x1, which one is your y1, and so on. So just pick one of those to be your first point. So I'll go ahead and say this is my first point. This is my x1. This is my y1. Okay. Then this is my second point. This is my x2. This is my y2. Okay. And then just plug it in. So m equals 2, this 2, minus 4 over 4 minus 3. 2 minus 4 is negative 2. Over 4 minus 3 is 1, so it's negative 2. Okay? So that's what we do if we need to find the slope and we're given a couple of points. Okay? So now, let's see how we can go ahead and graph if we're given the slope and the y-intercept. Because I said that we make use of y equals mx plus b to graph these. Okay? Well, let's suppose that they gave us y equals 2x plus 1. Okay? The first thing we do is note, what is the y-intercept here? So this is the y-coordinate of the y-intercept. So I go up 1. Boom. That's my first point. Now I apply my slope. Now the thing to note about the slope is that it is rise over run. Okay? So my rise here is 2. And my run, which is the denominator, note that if it doesn't have a denominator listed, it's 1. So I go up 2, right 1. Hey, there's a second point. So that means I can go ahead, make use of my line tool here. Go ahead and get this nice graph going. And there we go. Okay. So use your y-intercept here, then apply your slope. Let's do another one. Let's say y equals 3/4 x minus 5. Okay? We start at the y-intercept. In this case, 0, negative 5. Boom. Place my y-intercept. Now my slope is 3/4. That means my rise is 3. 1, 2, 3. My run is 4. 1, 2, 3, 4. There we go. Now we have 2 points. Bam. Bust out your line tool. There you go. That's all there is to it. Okay. Apparently the toughest part is putting those arrows on the end. Everybody just ignore how horribly I failed at that, alright? So, when we're given slope-intercept form, graphing these equations is pretty easy, but unfortunately, sometimes we're not given it in slope-intercept form. So in those cases, what we need to do is we need to manipulate them so that they are in slope-intercept form. So let's go ahead and see what that looks like, okay? Let's suppose that somebody gave us y equals, let's actually say they gave us just 2x plus y, give this a little bit of work here, equals 4. Okay? So when you're getting it in slope-intercept form, the thing to note is that it's y equals something. So all you need to do is solve for y. So to solve for y, I need to move this 2x to the other side. So I'm going to subtract 2x from both sides. This gives me y equals negative 2x plus 4. So I start with my y-intercept, and I apply my slope of negative 2. So that's down 2, right 1, because the denominator is implied to be 1. Okay? So now, get out your line tool, connect those points, and you're good to go. Okay? So solve for y, and then once you have your y, use your y-intercept. That's your first point. Apply your slope. That'll give you your second point. Okay? Let's do one more of these. Let's say negative 5x let's just say positive 5x. 5x plus 3y equals 15. Okay. So for this, we need to solve for y. So I'm going to move the x to the other side. So I'm going to subtract 5x from both sides. Okay. This gives me 3y is negative 5x plus 15. Now to solve for y, divide both sides by 3. We get y equals negative 5/3 x plus 15 divided by 3 is 5. Okay? So now, start with your y-intercept. 0, 5. So I just go up 5. Apply your slope. Down 5, right 3. And then, just draw your straight line. Okay. And that's all there is to it. Now, the last type of lines I want to talk about here are vertical and horizontal lines, because we've always, in all of these, we've just been dealing with lines that have slants of some variety. So let's go ahead and discuss what these horizontal and vertical lines look like. So vertical lines will be of the form x equals a. Horizontal lines will be of the form y equals b. So this is a horizontal line. This is a vertical line. And to see why this creates a vertical line and why this creates a horizontal line, let's take a look at an example. Let's say x equals 3. Okay? So x has to be 3. Note, it doesn't say anything about the y. So my y could be here, 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 etc. So that means that it's just a vertical line here. Okay? For the horizontal line, what if I had y equals negative 2? Well, in that case, down to this, I know this has to be my y. It says nothing about my x, so my x can be all of these. So that means that this is going to be a horizontal line. And that's it. Okay. So hopefully this makes these graphing of these much easier and a bit more straightforward to everybody. If you want to see more examples, please do let me know. Otherwise, I will see you in the next video.